So yes, the talk today is Hadoop, where it came from and what's next. It's a bit of an experiment for me, so please give me feedback. If you have questions, stop and ask them. You're getting the beta version, so feedback very welcome. So who am I? All right, so I've been working on big data since '96. Previously, I did search, and then we was what I like to call the midwife of Hadoop. Nobody's fighting for that title. I built and managed the team at Yahoo that took Hadoop from a prototype to what it is today. And then we spun that out into Hortonworks, the company. All right. I'm also a Pasadena native, so it's great to be back. Yep, they're going all over the place. There we go. Yep. Okay, so we start with what is Hadoop? So let me just ask, how many people here actually have used Hadoop in some way? So pretty good, about half. And how many people here aren't familiar with Hadoop, at least what it is or what it's for? All right, so great. It's tremendous to see that much interest and uptake in the product. So Hadoop is the open source big data platform. I used to say A, but at this point it really is the. I'll talk more about that later. So it's really got two components. Yarn, which is a compute layer that lets you run sort of arbitrary jobs on a cluster of computers, and HDFS, the distributed file system, which lets you take your data, break it up into chunks, and store that across a cluster of computers. So you latch these things together, and it lets you use up to about 5,000 computers as a single computational and storage resource to get really large jobs done. So it's scalable, right? All you have to do to make it bigger is add more computers, and lets you effectively process and store up to petabytes of data. It's very reliable. It's self-healing. As hardware fails, it just keeps working, right? As opposed to a lot of high available systems where when it fails, the operator can do something to restore service. Hadoop is built for a world where you run thousands of computers and they fail every day and nobody fixes them. Your job just keeps working. It's very flexible. It can store pretty much data in any format. It's got security, multi-tenancy. Lots of people can use it simultaneously, and it's very economical. Right? The software is open source, meaning you can download it and use it for no fee. You can change it, modify it, whatever, and it runs on commodity equipment. So nothing fancy. You can go down to Fry's Electronics, buy some computers, lash them together into a Hadoop cluster. If you lash a lot of them together into a Hadoop cluster, that's what they look like. Right? So that's one of the early Yahoo clusters. I have some hardware stats. I don't think I'll read those to you, but it takes sort of, a typical Hadoop computer is maybe 4 to 8 cores, 4 to 12 disks. You see them smaller and bigger, but so you get a lot of storage and a lot of compute in one of those boxes. And then these days we're tending to see white box 10 gig switches on top, so you get a tremendous amount of bandwidth in one of these clusters. When you sort of do the math on one of these big clusters, you're seeing terabits or even terabytes of data per second being pulled up off disk and processed. And there aren't too many, supercomputers on Earth. You're in the supercomputer category when you talk about that. So one of the things that you really have to stress to understand Hadoop, you really have to understand the cost advantage of Hadoop. This is a slide from VMware, which is a child company at EMC, which makes fans and NASs. So I really like using this slide to emphasize the point, right? Hadoop storage is 20x less expensive than NAS storage and 40x less expensive than SAN storage, which is sort of traditional big data storage. So that factor of 20 really, really matters when you start thinking about what can I do. One of the limiting factors for a big data project is how much money you have. So if your dollar goes 20x further, that matters. And this is just a slide about storage, but the thing to remember about Hadoop is when you buy your storage, you're also buying your compute infrastructure. You're buying a supercomputer cluster by the time you're done lashing it all together. So cost advantage matters. So the early history of Hadoop. So there's really kind of two threads that came together to form Hadoop. One was the Yahoo search team. From 1995 to 2005, the Yahoo search team built sort of 4 generations of systems to crawl and index all the data we could find from the web. That started out with tens of millions of pages and ended up with tens of billions of pages. So when you're collecting tens of billions of web pages, that's big data, and there just weren't any existing systems to manage that. So we built bespoke systems to do that over and over again, figuring out how to do this. But then in 2004, Google published their paper on the Google file system and Google MapReduce. And this really sort of electrified the wider community. We looked at that and said, yeah, these design choices all make sense. We've built systems just like this. But these guys have done a really great job of presenting an API on top of their work that will let their storage and processing be reused by lots of people in lots of different projects. So we could take the data that we have and the systems we have and really democratize them. And so the science teams we worked with were really excited about this. They came down to my office and started pounding the desk and saying, you crawl the web, you have billions of web pages. I want to be able to explore those. Right? I can do better, I can do good science on that data. So give us these APIs. So we started something called the Juggernaut project, which was going to be an open source distributed file system and MapReduce engine inspired by the APIs published by Google. We were going to do it in open source because we thought that was a great way for Yahoo to differentiate itself. Right? Google had written the papers. They had more research scientists than we did. We weren't going to write smarter papers in response. But if we open sourced it, then the reasoning was scientists all across the world could use this when they were getting trained, would come out of school trained on our version of MapReduce, and would think of Yahoo as a destination to do big data. Right? At the time, we were in a war for talent with Microsoft and Google, and we really weren't on the map as a big data company. Right? So that, and beyond the kind of a recruiting aspect for not really so much for the people to build the system, but the scientists to build Yahoo search and Yahoo advertising. We also were really focused on, we've built 4 versions of the crawling system. Yahoo had invested a tremendous amount in BSD, which was now obsolete. We built a lot of technology in-house as well that was just not continuing to be relevant. So we didn't want to build another proprietary solution for big data. We wanted to build something and share it with the world with the hope that there'd be a community that would help invest on it, and that together we could build and maintain a system that was better than Yahoo could build alone. So those were kind of the goals of the Juggernaut project. Then in parallel, Doug Cutting implemented his own version of the distributed file system in MapReduce in a project called Nutch, which was an open source search system. Doug Cutting was someone who was associated with Ghost and Overture. We were introduced to him through that, actually. And then he joined Yahoo, and we became aware of his work. So after a lot of discussion, we kind of joined forces and Hadoop was born. He took the Nutch software and created a new project called Hadoop. We took the team that had been building Juggernaut, which was a bunch of search engineers who built 4 web-scale big data systems before, put them together with Doug, and started working on Hadoop. So that's what the team that I built and managed did from 2006. They're still doing it today at Hortonworks. So that's kind of where it started. So at that time, Hadoop was a very simple system. There was MapReduce, there was a file system, and there was physical hardware that we ran it on. I'll show you a graph later of all the components in Hadoop today, so just remember that slide. So what happened? So we started building this thing. The original conception was we're going to replace Yahoo's infrastructure for crawling the web and indexing all the data we find, meaning tearing all the pages apart and building inverted indexes that are used for search engines. Right? But to do that, we needed to make Hadoop work on 1,000 computer scale, because that's how big that problem was. months, and when we started Hadoop, worked on 10 computers. So this was going to be several years of work. And we needed to do something to convince our bosses that we were doing something. So what we decided to do was put out some clusters for Yahoo scientists. So they were demanding access to our data. We said, okay, we'll put up some 30-node Hadoop clusters. And you can use those. You can write some papers. You can get some results that make web search better. And our bosses will see that the Hadoop project is generating value for Yahoo. That worked. They did write some papers. They did get some results that improved web search. But something else happened very quickly, which really caught us by surprise, which is they came back and said, I've prototyped a new system for ad ranking or search suggestion or a whole bunch of things. I've come up with a new prototype algorithm and process on Hadoop that I want to put into production. Right? I want these jobs to run every 15 minutes to upgrade the live serving systems that Yahoo runs. And if you do that, ad revenue will go up at Yahoo. And search relevance will go up at Yahoo. And that was not our plan, but all of a sudden, that was a compelling argument. We found ourselves in the business of basically running a data cloud, right? There was all these science teams who were prototyping on Hadoop, build it, and then coming to us and saying, help us run this in production. So we found ourselves running clusters of ever-growing size, doing these jobs. This became our job. We stopped being a search team and started being the Hadoop service team for Yahoo. And that just grew and grew and grew till finally, as you can see in this chart, we had about 40,000 computers and 350 petabytes of storage in Hadoop clusters that we were running as a service for teams inside Yahoo. So we had roughly 1,000 monthly users and hundreds of projects, all on these shared clusters. There wasn't one cluster of 40,000 machines. It was roughly 20 clusters. The biggest ones were around 4,000 nodes, but still huge clusters, lots of interesting stuff. So why did it take off like wildfire inside Yahoo? Well, this was a very early project. One of the science teams did, where they took this upper chart here is sort of the auto-suggestion you get as you type in the search box. So Yahoo actually built this feature before Google did, right? Where as you type, it suggests other searches that you could use. So that's a combination of spelling suggestions and popular searches. So the guy who did this had been working on working in C++ on one machine for years to build the first version of this feature. And the problem is, he spent half his day doing IT and a lot of his day, finding the data, moving it to a machine where he could process it, selecting the subset that he could fit on that machine. Just a lot of work around getting ready to do work. And then he had to write everything in tight C++ because he only had one machine. And it had to be efficient or it would never end. It would literally run for weeks. So he took the sort of core algorithm that built the index that was used for this feature and rewrote it on Hadoop. Before Hadoop, it took 26 days to run on one computer. After Hadoop, it ran in 20 minutes on one of these 20, 30-node clusters, right? Before he'd written it in C++, and it had taken him 2 to 3 weeks just to write this indexing software that ran for a month. Now he rewrote it in 2 to 3 days on Hadoop because he could use Python instead of C++. Hadoop gave him a framework where he didn't have to do a lot of the work. So this was really eye-opening for the science team and for us, because what you're seeing here is just a huge explosion in productivity, right? It's not very often that you get more out of your scientists by, if you find something that lets your scientists be 10 times more productive, you buy some of that, because especially in our game, the scientists were the limiting feature. How fast they could produce and test ideas was the determining feature for how fast Yahoo Search and Yahoo Advertising got better. So, and when you see these things running so much faster, that doesn't just mean that you get to the answer faster. That means you get to test 10 times more hypotheses in a month, right? So, it's not, research isn't predictable. The first idea might not be the right idea. So if you can explore 10 times more hypotheses, you're just vastly more productive, right? You wind up investing in things that work. So this is why Hadoop exploded, as shown in that previous graph. All right. So beyond Yahoo, of course, lots of things happened as well. From the beginning, we were taking all of our work, putting it into Apache, building Apache releases. So from 2006, there was already, when we started, there's some people who've been using Nutch MapReduce, and they immediately started using Hadoop. And we got their feedback and testing and support. So the community was, not just consuming Hadoop, but also, as that arrow shows, putting stuff back into Hadoop. Bugs, new ideas, improvements. But then by 2008, we really saw something happen, which was very exciting, which was other companies, mostly in the Valley, were picking up Hadoop and building their own sort of systems on top of Hadoop, and we're starting to contribute back not just patches to Hadoop, but whole new systems on top of Hadoop. Facebook produced Hive, Twitter has produced a whole bunch of libraries, LinkedIn's produced Kafka, a whole bunch of other things. So these companies were just making massive contributions back to the ecosystem, as well as using our stuff and helping spread the word, which is all very exciting. And then this thing has just accelerated from there. From about 2010, we started to see companies really step up and take Hadoop as a service and provide Hadoop as a service to third parties, right? So Cloudera and Amazon were really some of the first, and now there's just a lot of companies doing it. I won't read the slide to you. And that drove mass adoption, right? We now just have lots and lots and lots of business entities pushing Hadoop into the marketplace. And that, of course, drives improvements into Hadoop, and the whole thing just steamrolls and goes faster and faster. So it's been very exciting to watch. So when we first started Hadoop, the Hadoop project, we joked that this thing was going to be so big that Google would rue the day that they hadn't open sourced what they've done, right? And entertainingly, they have a verb in Google now, which is to be Hadooped, right? So it actually happened, right? Yahoo actually buys companies that are built on Hadoop, and that makes their integration easy, right? Google buys companies, and they're built on Hadoop too, and that's a pain for them. So it's kind of exciting. So Hadoop has seen off many competitors over the years. As in the early days of Hadoop, you would just it seemed like every month or two someone would show up and say, "I have done Hadoop, but it is in OCaml, and it is therefore better in all ways," right? Or I have done it, but it is in Python, and I have implemented this thing better, right? Or it's in C++, and we're using it in the LexisNexis infrastructure, and we're going to take it commercial, and it's going to be better in all ways. Baidu also did it in C++. It was going to be better in all ways. All these companies, Microsoft has a Hadoop-like thing called Cosmos done in C++ that was going to be better in all ways, and they invested a tremendous amount in it, right? Lots of other groups as well. The database community, several database companies implemented MapReduce and said, we are the enterprise Hadoop. They actually had a conference. One of them had a conference the day before the first Hadoop World, where they said, this is the enterprise Hadoop conference. Come by, ask about it. Right? But so there's been a lot, everyone has said Hadoop is too slow, it's in Java, there's nothing new here. Databases have been doing all this for years. We heard a very eminent scientist say that. It doesn't have ACID, it's not highly available, it's not secure enough. There's been all these criticisms over the years and all these alternatives. But Hadoop has just triumphed and steamrolled all these things and grows and grows and grows. And most of these things aren't relevant, aren't even in the discussion anymore. So why? One has just been the deep investment from Yahoo, right? At the time, I didn't really appreciate how unique what Yahoo was doing was. We put more than 300 person years into this project and open sourced all of that, right? Because, as I said, there was a strategy, there was a reason Yahoo was doing it. It was giving us the tools to build all the layers on top of Hadoop, right? All the science and applications that make Yahoo Search, Yahoo Advertising, at this point, every other piece of Yahoo work better. But it is pretty unique to have a company put that much IP out into the public domain. And we had thousands of users and hundreds of use cases pounding on this thing. And we solved some of the world's biggest problems. Right? None of these other frameworks had that unfair advantage. Right? It is really a community open source project. It has many contributors across an entire industry now. I mean, at this point, there are thousands of people regularly contributing to the Hadoop ecosystem. And the Apache Foundation provides continuity and really clean sort of intellectual property, right? No company owns Hadoop, and that's actually very important, right? Because companies go up, companies go down, but you can have confidence that you'll have access to this code later because it's owned by the foundation. Let's see, and the economics are just right? As I talked about before, there's a real cost advantage coming from the open source and the commodity hardware. Just as an example, Yahoo has one system administrator for about 8,000 computers. And at scale, that really, really matters because in most IT organizations, people are the largest expense. Right? When you run Hadoop clusters at scale, that's not the case. Right? The stuff just works. So you're not spending all your day fixing it. There's a learning curve to get there, but once you get to scale, the economics are amazing. And it is just simple and reliable at that scale. And Java actually is on the plus side, right? Java turned out to have really good tooling, garbage collection, things that made it really easy to get it right the first time and to onboard new contributors, right? It turns out that if you're taking patches from 1,000 people, C++ is a horrible language to be working in because it's just too easy to make it break, right? And it's also very easy to build community in Java because there's more Java programmers than any other single language in the world, right? So it's very democratic. One more use case from the past. So we did actually port the biggest application in Yahoo Search onto Hadoop. It was a fun use case, but this is taking every web page we found, tearing it apart, pulling out all the links, and then sorting those links so that you know for every page what are all the pages that refer to it. Right? This is the key to computing things like PageRank and other things that actually turn out to be more important if you work on search. But so you do a whole bunch of algorithms on this, and in fact, one of the things that Hadoop put to rest was a system called Dreadnought, which we had built before we built Hadoop. It was a C++ MapReduce engine, right? It ran on 1,000 node clusters, and it was a pretty good algorithm. So why did we decide to port off that onto Hadoop? Well, first of all, it was custom C++ and it wasn't scaling. It was hard to make it run at 1,000 nodes, and we wanted to make it run on 2,000 nodes, and that was just going to take another rewrite. We didn't want to do that. We wanted to leverage the scalability of Hadoop and the resilience that we talked about. We also wanted the web map team to focus on mapping the web and not on building infrastructure. So we decided to do the port, even though we had a C++-based solution. And the result was that the port ran 33% faster on this Java framework that everyone was always complaining was too slow than the hand-tuned C++ thing that we had before. And this was on Hadoop 0.18. Hadoop is a lot faster now than it was then. So why was that? It was the error correction. Right? What happened in the old cluster was it ran faster than Hadoop when it ran, but then nodes would fail. And the 1,000-node cluster, when you're doing web indexing, you're just hammering on the disks. Disks fail. Right? And when disks failed in this system, it took operator intervention to get it going again. So it spent half its time being repaired. So when you factored that in, Hadoop was faster on day one. Today, Hadoop would be faster even when the thing was running because they've optimized it a lot. All right, so this was a big job, as you can see. It took in hundreds of terabytes of data. It ran for like a month. Right, all the steps together. The longest step took 70 hours for one MapReduce job. And Hadoop was able to do that, right? So this was a big proof point for the world, which is Hadoop can handle big work, right? So one of the reasons people choose Hadoop is because it's proven to work at scale. If your business grows, Hadoop can grow with it. All right, so enough about the past. Where's Hadoop today? So remember that picture with two boxes on it? Right. So this is a sketch of the Hadoop ecosystem today, vastly simplified. But so at the bottom you have HDFS, the old standby. Now we also have something called Hive, metadata server, or HCatalog, which lets you manage things that look like SQL tables on Hadoop, which has been a big improvement because SQL is has been a language that has brought many more people to Hadoop. And there's another storage system I listed here called Kafka, which is really at the center of real-time streaming. I'll talk about that more later. And then instead of MapReduce, we have Yarn, which is a system that lets you run all kinds of different compute models. And MapReduce is still there. It's just one of the compute models. We also have a number of other ways that you can program the computer at a higher, more productive level. Right? MapReduce is sort of the assembly language of Hadoop today. Right? People usually program in a higher level language. So we've got a number of sort of procedural languages such as Pig and Spark and Cascading. Then we have a bunch of different SQL implementations that let you, interrogate, query your data directly in a higher level language. Then there's a bunch of streaming things, and there's a bunch of service things happening too, such as HBase, which is a NoSQL store, a lot of other things. And as I said, this is just a sketch. Also relevant is at the top of the stack, there's now lots and lots and lots of products and services and open source frameworks that you can use with Hadoop. I couldn't begin to enumerate them. And down below, it's not just physical hardware anymore. A lot of people run Hadoop in a virtual environment, in a public cloud, and other places. So your options for using Hadoop have grown tremendously, as have sort of the use cases, right? A lot of organizations start with just using Hadoop. Hadoop as an archive. They use it as low-cost storage. As the VMware slide said, Hadoop is cheaper than most anything else. Another thing that we saw a lot of traction on early and that just keeps growing is data warehouse optimization. Right? When you're building a big data warehouse, you do a lot of data archival, a lot of ETL, moving data around, transforming it. And then you do a lot of sort of science exploration, discovery, and all of this stuff is now happening on Hadoop because Hadoop is more cost effective and more flexible. In a lot of cases, Hadoop is actually replacing the existing warehouses. Not in kind of core warehousing, business. Nobody's closing their financials on Hadoop that I know of. That would be an interesting one. But it's not really optimized for that. But when people were trying to use Hadoop for managing all the logs in their company, when they were using warehouses for that, they're now using Hadoop, right? And it's going into ever more use cases. There's lots of kind of horizontal things where we see Hadoop across a lot of industries. I'm not going to read you this slide, but let me just say, it's here, you can see it's in a lot of verticals, it's in a lot of horizontals, it's used in a lot of places. This is kind of an application, this is a sketch of how Hadoop is often used, sort of in an end state. We talked about the sort of early things where people use it as an archive. What you see here is kind of the kind of traditional Hadoop app that we saw evolve, where you see Hadoop used. Actually, let me flip forward to the example. So here's an example, one of those early applications I told you about that drove Hadoop's growth. This is the Yahoo homepage. When you visit Yahoo's homepage, they select news articles that are relevant for you. They do that based on your interests that you've expressed by where you've gone in Yahoo. So this is done by a combination of Hadoop and other systems. So when you visit Yahoo, there's a serving store that looks up your preferences, not on Hadoop, but it looks up your preferences and selects a set of articles that have been tagged as relevant to that preference. For example, it might say, this is a sports enthusiast who really cares about football. It might say, this person likes cars or cat videos, right? And that will drive what articles you see as you visit Yahoo. Now, what happens next is you click on something, you don't click on something. All that's information that streams back into Hadoop, right? And then every 15 minutes in there, or 5 minutes in their original implementation, Hadoop would run some MapReduce jobs, look at what you've done, and from that we would infer, right? This person has clicked on a whole bunch of new articles. It looks like they are shopping for vacations. There's an interest in vacations, right? And that would get tagged. So 5 minutes after you'd gone looking around the site, Yahoo would have learned that you want to see information about vacation destinations. That would be a new entry in that serving store. And then every month or so, the scientists would go and take everything that had happened on Yahoo for the last year, including all the new data, and they would do some machine learning and figure out how could we do a better job of categorizing, what people are interested in from what they do in Yahoo. That's that upload, right? right? So there's Hadoop used in research, there's Hadoop used in production, and then there's these dedicated serving stores that are interacting with the user in real time. So that's what this architecture shows you. You've got Hadoop on the bottom doing those big long research jobs, and also doing those fast 15-minute jobs or 5-minute jobs. Now there's another layer that's also emerged. In the Yahoo solution, this was all hand-coded, but now there's a set of generic solutions to use, so that as events come into the system, you can take immediate action. You can look at them and immediately update the serving store. For example, if someone goes to an NFL page, why wait for 5 minutes to tag that he's interested in football? Let's tag it right now, right? And then the batch system can make wider inferences about that later. But if certainly in a lot of instances, in personalization, in advertising especially, time is money. If somebody is expressing an interest in something now, you want to get that information into the serving system now, right? He'll have moved on, he'll have made a purchase, he'll have, moved on to another problem in 15 minutes. So these streaming solutions give you instant results. You have a number of those that are pretty tightly integrated or at least used in concert with Hadoop listed here. So that's kind of a modern Hadoop architecture. And those things on top are just your classic website. You've got things like Apache or Tomcat serving, building web pages, and something like Cassandra or MySQL storing information about users. Right? When the web page is built, Hadoop isn't touched. But Hadoop is constantly pushing information up into that system, and that system is constantly sending logs back into Hadoop. All right. Forward. Okay. So how do you get Hadoop these days? Well, there's no shortage of options, right? You can download VMs or use cloud sandboxes from any of the vendors. You can get it as a service. You can get it hosted. You can work with one of the distribution providers to host it in your own data center or run it on your own cloud. All of the enterprise vendors sell Hadoop too. You can get Hadoop from IBM. You can get Hadoop from Oracle, amazingly. Right? So, and then of course you can do it all yourself. You can go to Apache and download the bits and build it, or Apache has a project that helps build those bits for you and assemble them together into a tested package. So there's no shortage of Hadoops. I'm sorry about the varying volume. Just let me know if it gets too loud or too quiet. But Hadoop is still hard, right? How many companies are up for do-it-yourself supercomputing, right? Designing and managing the combination of hardware, operating system, software, and network is complex, and Hadoop talent is scarce and expensive, right? And then all these vendors who are trying to sell people Hadoop are selling slightly different things, right? And beyond that, a lot of these really valuable Hadoop solutions that we're talking about adding value are practices, not products, right? You have to write software to solve your problems on top of Hadoop. It's not snap together technology, right? It's a cutting edge framework for building new software to solve problems, right? So why does anyone deal with all this complexity, right? Well, my old sort of traditional answer to what is big data is, you have a big data problem when you don't, your systems are failing, right? When the thing you need to do is just not financially feasible with the tools you use to do it, right? We talked to a lot of people in the context of selling Hadoop from Hortonworks who are spending tens to hundreds of millions of dollars on traditional data systems. And hundreds of millions of dollars, literally every year, just to buy the software to run these systems, software and hardware. So, and they were looking at their, business doubling every year, and they, the incremental cost of doubling those systems, they couldn't double those systems. There wasn't enough money in their businesses. So they either had to go out of business or find a new technical solution, right? The costs had become prohibitive, or sometimes the tools just don't scale at all. I was talking to some people today who said, a vendor came in and said, give us your data, we'll map it all out, we'll provide you with great higher level solutions. And they gave them a sample of their data and then crushed the vendor's product, right? It just couldn't handle it at all, right? These traditional data products can't handle these web scale problems. So, if you don't have any other solution, do-it-yourself supercomputing starts to sound more appealing, right? Right? Maybe you're building a data business, right? Our host here is building a data business, right? Absolutely, managing petabytes of data is just at the center of their business model, and they need to do it cost effectively. And of course, there are lots and lots of success stories on Hadoop, right? And there's lots of big data businesses being built on Hadoop. So there's reason for hope. There's reasons why you should adopt Hadoop, even though it can be hard. So some quick guidelines for bringing Hadoop into your organization. I get asked this a lot. And I think the best piece of advice that I have is start small, right? Don't start by saying, we're going to architect a new data lake where we're going to take every piece of data in our business and put it into Hadoop and buy 1,000 nodes. It's going to be great. We're going to change everything, right? There are some CIOs who've done that and some CIOs who've done that successfully, but it's a scary place to start, right? And if you're trying to work bottom up, you're not going to succeed in selling a $10 million Hadoop project. So it's really easy to find quick wins in a lot of organizations. Just some examples here, right, that I've seen. Right? We worked with a medical provider who, with Obamacare, they're incented to, you're paid based on how sick your clients are. And they looked at their data and found out that people, according to their data, people were recovering from amputations in an average 18 months, right? By, the chance of you being coded as having an amputation 2 years after it happened was less than 50%, right? So they just were losing track of things about their patients, right? So they were using it just to scan through all their data and find interesting, and find things about their patients that their doctors should know and that their insurers should know, right? So that was, very simple work, very valuable to the company, and hopefully very valuable to the patients too. You'd like your doctor to know that you have an ongoing condition, right? People are recovering from schizophrenia, all kinds of things. So predict the daily peak load based on historic data, or predict, customers coming into your business. These are sorts of things we've seen people do with Hadoop. Or just scanning, really easy, just scanning a lot of documents. One thing we saw was the New York Times go through and convert all their documents to PDFs on Amazon. That was a very early Hadoop win, right? Doing that with their traditional infrastructure would have taken forever, right? They did it in a week on Amazon. Reduce the cost of ETL is sort of a classic win with Hadoop. People that with big data warehouses can spend a tremendous amount of money, and often these processes to load data into the warehouse just take too long. Hadoop, you can make it go much faster for much less, right? So these are just the kinds of examples of early first projects you can do with Hadoop. Right, the hardware, you can run it in the cloud. It can be very cost effective at small scale just to use public cloud to prototype Hadoop. Otherwise, you can take 4 to 10 nodes. It doesn't need to be big. And in a lot of cases, repurposing old gear is perfectly cost effective. Right? It may not be optimal, but you can learn a lot about Hadoop. You can show your management why Hadoop can add value with a very small amount of hardware. And then build on your success. Right? After a few projects, it's much easier to do capacity planning. It's not just guesswork to figure out how much Hadoop you need if you're actually using Hadoop. Right? Of course, success builds organizational competence and confidence. And growing incrementally is, just a pattern that works very well with Hadoop. Every time you add a new data source to a Hadoop cluster, the Hadoop cluster becomes sort of incrementally more useful as a network effect, right? And that's, we saw this at Yahoo. We sort of accidentally built a giant, data lake, data warehouse, whatever you want to call it, where every time we took on a new project for a new team, we added more data, and eventually the sort of cross product of all that data just drove a tremendous amount of innovation, and just the excitement of having all of Yahoo's data in one place, just spurred a lot of innovation, as I said. But so it's not unusual to see, like a Hortonworks customer, we would see people start with 5-node clusters. And 6 months later, a year later, maybe they're running in 10-node clusters, 20-node clusters, and they'd solved the business problem. That it was deemed a success. But they'd run for 2 years of that kind of scale. And then you talk to them again, and all of a sudden they say, yes, now we're going to 300 nodes, right? because the organization has learned how to use this thing, and we found more use cases, and now, we're not just doing archival and incidental processing. We're going to build a golden record. We're going to take every interaction that any customer has with our giant retail company, and we're going to combine that into a single unified view so that whenever they interact with the company, we know all about them, and we're going to do that with Hadoop, right? And that's going to, drive customer retention for us, customer satisfaction for them. Everyone's going to win. It's very exciting to see that kind of growth. Okay, deep breath. So I'm going to change gears again and just sort of talk about some future trends as I see them on Hadoop. One, things are going to get easier. We talked about how Hadoop can still be hard, but as I said, there's this huge ecosystem of people, from the big do-it-yourself guys like Yahoo, security company, the security community in America. All these guys are investing in Hadoop. The Hadoop distro companies are, the cloud hosting providers are, all these other guys, down from researchers up to Yahoo, Twitter, Facebook, are putting code into Hadoop. So Hadoop is improving all the time. One of the big concerns I hear all the time is, but what about fragmentation? The Hadoop market is clearly fragmented, right? When you say I want to run SQL on Hadoop, you get to choose between Impala or Stinger or Spark or Hawk. I can name a few more, right? There's a lot of, anywhere you look, there's multiple solutions, and there's different vendors pushing variant solutions. And, a lot of these things are partially proprietary. This is very confusing if you're trying to build a business on top of Hadoop. And there's no obvious process by which these things are all going to converge into a single answer. So, I had somebody following me around at a conference last year saying, admit it, Eric, Hadoop is going to fragment. Hadoop is going to fragment, right? And the analogy everyone likes to draw is to the Unix ecosystem, right? So this is a graph of the various flavors of Unix, right? So, right, and as you can see, there's this sort of explosion after BSD. And I was part of, when we first launched Hortonworks, I stood up on stage in 2011 and said, we want everyone to use Apache Hadoop because we don't want this market to fragment. We want everyone to benefit from there being one flavor of Unix. Well, okay, that's not happening. But, I've been watching and thinking about this for a few years since then. And something occurred to me, which is, let's look at this Unix lost decade from 1980 to 1995, right? What's the difference between Unix in 1980 and 1995, right? I mean, it started out as a niche OS, but by 1995, it was at the center of, the database and client-server revolution in enterprise. It was everywhere. And the dot-com revolution was built on Unix, and not one Unix, on all the Unixes, right? We used to have to deal with DEC Unix and HPIX and Sun Unix and, BSD, OpenBSD, FreeBSD, NetBSD, you choose, right? So it sounds awful, but we went from, in that circumstance, Unix went to rule the universe. We built tools to deal with the fragmentation. And these competing vendors, they didn't just confuse us. They innovated like mad, right? This is competition, right? They built new features and new things to differentiate, and then they copied each other like mad, so those new features got pushed into all the MCs sooner or later. And they worked to make it easy for people to adopt their stuff. So the world adopted Unix because it liked its basic APIs, and real problems were being solved, and solutions were being sold on Unix, right? And I think fragmentation is just part of that process, right? I think that life would be great if on day one, the AT&T had unveiled the perfect Unix for the future. But nobody's perfect. Nobody has that insight, right? Central planning has a bad track record, right? So what we have is a messy evolutionary process that drove success in the case of Unix. And you can pick a lot of other examples. Web browsers are another one, right? What a disaster, but they have changed the world, right? Databases, right? We don't just have Ingress anymore. It would be so much easier if we just had Ingress, wouldn't it? But, we have open source solutions, we have proprietary solutions of all flavors and sizes, but somehow they've changed the world. So what I conclude from this is that fragmentation is just an inevitable result of an aggressively growing ecosystem, and that's what we're looking at. Hadoop is an aggressively growing ecosystem, right? It's providing solutions, and we should expect a lot more innovation from Hadoop. And one of the things that we are seeing is just that that problem that you have to do custom coding to use Hadoop. Lots of people are trying to address that, right? Because programming for customers is just not economical. So a lot of this innovation I expect to see is in terms of sort of repeatable, consumable solutions on top of it, which will make it much easier for many more businesses to consume. All right. Prediction 2, there's going to be more Hadoop. Right? And this is probably not a surprise for me. The data hub lake pattern is really compelling for many enterprises. Right? What you see Hadoop grow into is the new central data repository, right? Where you land and archive all the raw data that your organization generates, and then you process it, clean it, build reports, do data science visualization, or push it to other downstream systems. Right? You do this because it saves you money and it supports data-centric innovation. As I said, as you put more and more data in one cluster, you can do more and more things. So this is kind of the architecture that we see in kind of any of the mature Hadoop shops. This could be Yahoo, this could be Twitter, this could be the NSA, probably. I've never seen it. Right? This could be a lot of businesses, right? And across a lot of sectors, where you see your transactional systems, your NoSQL systems, your new data sources, all this stuff gets pushed into Hadoop. Stuff gets pushed back from Hadoop into those systems, as we talked about. And then people are interacting directly with Hadoop, and Hadoop is also being pushed downstream to tools, traditional and new, that let them be more productive with that data. So what we're seeing is Hadoop just become the hub, the new hub for a lot of enterprises. And I think that pattern is just accelerating. So now, as I said, this is just an example of some of those new tools and what a data lake lets you do is very interactive data science, business intelligence directly on Hadoop. So there's tools that let you do that. So data lakes happen, right? Time and again, we see organizations move to this model because of these networking effects I've talked about. Yahoo was a data lake. That was kind of accidental, and we built it incrementally. Back to my point, you don't have to start this way. If you just start solving real problems with Hadoop and iterate, you get here. And that's why I think we're going to see a lot more Hadoop, is that it just keeps winning a larger and larger share in enterprises. And finally, some cool new stuff. So these are just some projects on the top of the stack that I think are worth paying a lot of attention to. Kafka I've mentioned a couple of times. I think it's kind of the solution for real-time streaming in Hadoop. You land your data in Kafka, then you can push it anywhere you want, including your streaming things like Storm, or onto your Hadoop cluster. It doesn't matter, right? It does what TIBCO promised to do in enterprises. Yarn is just starting, right? Yarn is the center of Hadoop, but there's a lot of innovation to come there. The Slider project is worth watching. This lets people run services on top of Hadoop, right? So we see a lot of excitement about things like Kubernetes and the cloud side. I think you're going to see things like that happening on the Hadoop side as well, right? Slider is an example of that lets you deploy things, NoSQL stores directly on top of Hadoop. It makes your jobs very much easier to write. Spark is an emerging programming model on top of Hadoop that's great for data science and machine learning. I think it's very exciting. I think we're going to see Hadoop become much faster via caching. There's a couple of projects to watch. Tachyon coming out of the Spark camp, and LLAP, Live Long and Process. Horrible name, in my opinion. But anyway, but this is coming out of Hortonworks, and these are just sort of caching technologies that make your data much more quickly available. I think that's going to, as I said, in a lot of cases, Hadoop's already faster than anything else, but this is going to help address concerns about Hadoop's latency and speed and just make it go faster. There's lots of new products, way too many to name. Just picking one sort of horizontal slice, data science, a couple of companies worth watching. OX Data is doing great machine learning tools. Databricks is providing a data science environment, as is Adato, right? So there's just an amazing proliferation of stuff on top of Hadoop. which as I said, I think is one of the key ways that Hadoop is going to get better and easier. So I'm going to pause and say thank you and answer questions. Questions?
Are you asking me posted anywhere?
Yeah, sure. I'll put them on. Well, I'll tweet where they are. There's my Twitter handle. So I'll put them up, and probably the group will as well on the meetup page.
Yeah, we'll have it.
Yes, on the meetup page as well. All right. Other questions? Yeah.
With the fragmentation of solutions, should we keep on the core solutions like Hive, BigSpace?
So the question is, given that there's fragmentation, should I stick to the basics? Is that a fair summary? I think that's really situational, right? I think that the advantages, the reason I think Hadoop will win is I think there's a common core that you can trust will be there and will be stable and will improve, right? And yes, Hive, and, in HDFS are in that common core, and you can do a lot with those things. But a lot of these new emerging things have great capabilities and are, custom built to solve certain problems. If you have one of those problems, it may well be worth, experimenting and working with the people that are producing those things. So I don't think there's one right answer to that. The great thing about fragmentation is you have choice, and there's lots of people with different visions pushing that into the market. So, you can't go wrong by sticking to the basics when you start out. But as you understand the space, I'm not going to say do or don't engage with any of these guys. I think that, they're all businesses and they're trying to drive customer value. So it's worth hearing their pitch and thinking about it. All right. Yep.
You were talking about using Hadoop in the cloud. So I was wondering, when you want to transfer data from one disk to another, it takes a lot of time. For example, 1 terabyte of data takes time. So how does Hadoop make it faster?
Well, Hadoop does not have a solution to the speed of light or the size of the network. Obviously, when you're starting to talk about petabytes of data, moving that is a major problem. Kind of what you see is people gravitate towards solution, building Hadoop where it makes sense given the flows of their organization, right? If your organization is already in Amazon doing things, well, then you'll, run Hadoop in Amazon most likely, right? And if you have an on-prem, huge traditional data infrastructure, then you'll probably build Hadoop next to that. I don't think I have much more to say than that, right? Large data is hard to move. The good news is, you mentioned terabytes. For a lot of businesses, we don't worry too much about terabytes, right? I happen to know from my web search day that at 1 gigabit per second, you can move 8 terabytes a day, right? And you can get 10 gigabit lines pretty regularly these days, so you can move 80 terabytes a day, right? So it's all a matter of scale and economics. Data can be moved. All right. Now I don't think what I said.
So it looks like from what I just heard from you, and so the Hadoop means big data, and big data means Hadoop. Things like the Facebook, Google, Yahoo, almost all the big companies investing in or develop something based on Hadoop. So can we say Hadoop is the only direction to dealing with the big data, or is there any other competitive solutions?
Oh, well, I meant to put my eye chart in here, but I forgot. So the next time I give this talk, I'll have my Big Data ecosystem eye chart. Right? There's 1,000 things going on. So no, Hadoop is clearly not. Just as one example, let's see. Right? I have some other big data technologies unrelated to Hadoop listed in this slide. I'm not projecting anymore, so that doesn't help. But so there's complementary technologies. I mean, you could argue, for example, Kafka is not really a Hadoop technology, or Storm is not a Hadoop technology. Those are complementary. They're used with Hadoop all the time. The same with Cassandra, Elasticsearch, all the sort of NoSQL stores. And there's a lot of other things happening in the ecosystem that people tend to combine with Hadoop. But where Hadoop really shines is kind of as your data cloud, as your data archive and processing engine, right? It's not really your interactive engine, right? So what you really see, there's kind of two hubs. We used to call them at Yahoo onstage and backstage. Hadoop is backstage, right? Where you have all your business processes on data. And there's really nothing competing with Hadoop except flavors of Hadoop. I mean, you could, if your problem is small enough scale, then the whole traditional database industry provides a range of solutions, right? If it's small enough scale and structured enough to fit into their models. But once the economics change, there's really nothing competing with Hadoop for your back office data processing. But for example, when you're building interactive systems where the user clicks, you provide a response, right? You tend to see NoSQL technologies there, right? A Cassandra or a React or something like that. So no, Hadoop is not the only thing, but it's this data lake is a kind of new sort of center of gravity in the enterprise that is Hadoop. So it's Hadoop and a bunch of other things. But
Your thoughts in regards to the shift towards like midstream processing approaches, and I don't necessarily mean like Storm versus Spark streaming, but more like fast parallel versus data parallel micro batch, and do you see a specific direction where all that's headed?
what do I think about the sort of evolution of these real-time streaming processing engines? I would say it's an evolving continuum. I advise a couple of companies that build some of those, so I'm certainly not, I don't see those, I see a future for that technology. I mean, I think it comes down to problem and fit. I think we're just going to see more of both. But I definitely think that there are a lot of use cases where just because, we've attacked the latency problem with Hadoop, over and over and over. We've gotten system latencies down from days to hours to minutes, and the Spark guys say they've gotten them down to seconds, or milliseconds. But nonetheless, these sort of streaming approaches it can be lower latency. They will often be lower latency and sometimes cheaper and lower latency. So it's really a problem fit issue. If what you're looking to do is respond to every event that hits your system, you should build a system that's sort of event-centric, right? And Hadoop is not event-centric, right? So I think there's going to be more and more use cases where that's valuable.
Do you see an inflection point where the purely batch-based MapReduce paradigm sort of dissolves into a pure midstream processing paradigm?
No, I don't see that inflection point. I mean, people like to write about how MapReduce is dead, right? Well, MapReduce is certainly less relevant, but it's been reinvented as Hive, which is exploding, and Spark, which is exploding, right? And Spark is directly competing for some of these sort of streaming use cases. And so I think that these things converge to some extent, and I think that what we'll see as Hadoop evolves, you're going to see these kinds of workloads just hosted on Hadoop because you need to store your data somewhere, and ultimately Hadoop starts with HDFS and data management. And once you're managing data, a lot of times you want to pick it up and transform it, and for that you're going to want these batch processes. But I think a lot of ingest is going to move to streaming, right? Because lower latency is good in a lot of businesses, right? And as the reliability and the simplicity of these systems improves, I think there'll be more use cases where it makes sense to use them exclusively. Yeah.
Can I add something else? So
in OpenX, we actually deal with low latency data as well. As we use Erlang and React for low latency data serving, and on the back end, we have the Hadoop process data in parallel and with massive amount of data. That is how our architecture is formed, and I think that
So just, I think I'll go for about another 5 minutes of questions, and I'll let you guys talk to each other and me after that. But so I'll take a few more. So did you have a question? No. So I saw a hand back there.
For startups, so we're trying to have chemicals. And
I missed a
what
word.
product is, if we will go with commercial, like OpenWorks, Cloudera, it will be the support costs where we'll have some content that. So what can we suggest with startup?
So let me see if I can repeat the question. So you're a startup, you're cost conscious, and you're trying to decide whether it makes sense to engage one of the Hadoop distribution vendors. So I think every business is different. I mean, it's a question of where you want to invest your time and talent, right? If you have a lot of extra bright programmers and you don't have a lot of money beyond the money you're committed to spending on them, it may make sense to self-support, right? And longer term, right, if data is really going to be at the center of your business, it may make sense to self-support and build that confidence. But there's a lot of other businesses where that's neither of those is the case, right? Where really bright programmers are at a premium and you'd rather be allocating them to your hardest business problems and spending a few thousands, tens of thousands, or in big cases, hundreds of thousands of dollars on a vendor is just, I mean, you pay every individual, smart programmer hundreds of thousands of dollars, right? So at some point, the economics just say we want to build our core competence somewhere else, and it makes perfect sense to invest in the vendor, right? So, but I mean, the biggest companies in the valleys aren't, and the smallest companies in the valley aren't. A lot of companies in the middle are, engaging with this.
I have a question about Spark. Looks like a Spark itself is kind of it doesn't need to run on Yarn. It has its own task management. It just uses HDFS. So do you use, and then they're all stacked, from the BDS stack. It's EDAS. The stack has all, from the top to bottom, has everything. So do you see Spark as a kind of replacement of Hadoop, or kind of?
So yes, the question is, Berkeley has published some papers that describe something called the BDS stack, which is an acronym for Berkeley for Big Data. It's Berkeley Big Data. But anyway, so is Spark going to replace Hadoop, or is it part of the Hadoop ecosystem? So I certainly, I advise Databricks. I certainly believe that Spark is part of the Hadoop ecosystem, which doesn't mean that people won't use it independent of Hadoop. People are now using Spark with data stacks, very confusing set of names, which is the Cassandra company, right? So people are using Spark plus Cassandra. But, as I talked about this sort of data lake, the thing to understand is that Hadoop is where the data is, right? And Spark is a great tool for processing data, right? So it just makes sense to combine them, right? And the Berkeley stack, I mean, you got to understand that that's kind of a research agenda, right? And various parts of the research agenda are at various places, and so a lot of those diagrams are things on the diagram are aspirational. Spark is a real product that people can use, and they can use it with Hadoop and have some great results. They can also use it independently of Hadoop and have great results. But in a lot of organizations, Hadoop is where the data is, right? And there's a lot of places, times where people want to use other tools. So I see them as very complementary. All right, so I'll hang around for a bit longer. We can take questions one-on-one, and I'll let you guys carry on with your evening. Thank you very much.